So first of all, what is an odds ratio? So an odds ratio is the ratio of the odds of an event in the intervention group to the odds of an event in the control group. So say, for example, the event is failing a driving test and the intervention is having driving lessons. Let's say we have 10 people and they all take their driving test. 5 of those people have had lessons, so they're in the intervention group, and 5 haven't had lessons, they're in the control group. Of those that have had the intervention, 1 has failed and 4 haven't failed or have passed. In the control group, those who haven't had lessons, 3 of them have failed and had the event, and 2 of them haven't had the event, they haven't failed or they've passed. So the odds of failing in the intervention group is the number of events, which is 1, over the number of non-events, which is 4, so 1 over 4. What's the odds of failing in the control group? Well, that's the number of events, which is 3, over the number of non-events, which is 2, so 3 over 2. So the odds of failing in the intervention group is 1 over 4. The odds of failing in the control group is 3 over 2. The odds ratio is the intervention over the control odds, which is 0.25 over 1.5, which is 0.16. So the odds ratio of failing is 0.16. Now let's look at relative risk. So the relative risk ratio is the ratio of the risk or probability of an event in the intervention group to the risk or probability of an event in the control group. So now here, when we're looking at risk, the risk of failing is the number of events over the number of events and the number of non-events. So the risk of failing in the intervention group is 1 over 1 plus 4, which is 1 over 5. And the risk of failing in the control group is 3 over 3 plus 2, so 3 over 5. And then the ratio of those will be 0.2 over 0.6, i.e. 1 over 5 over 3 over 5, and that's 0.33. Now we know that an intervention is effective if the relative risk is less than 1, or the odds ratio is less than 1. If the relative risk is 1, then the intervention has made no difference at all. Now, I find odds ratios and relative risk ratios very difficult to remember. And the way I remember it is thinking of horse racing. If we think of our betting odds, so horse racing, we talk about odds, we don't talk about relative risks. If you think of a horse being 4 to 1, that's essentially 4 to 1 to lose. So the odds of losing. So 100 to 1 obviously has got a very good chance of losing. 2 to 1 has a much better chance of not losing. But 4 to 1, for example, is the odds of losing. Now in 5 races, therefore the horse will lose 4, they'll win 1. So therefore the odds of winning is 0.25, 1 over 4. But the risk, the probability of winning is 1 over 5. So when we talk about odds, we're talking about the ratio of an event happening over the ratio of the event not happening. Whereas we're talking about risk, we're talking about probability. So the number of times the event happens over the total number of events. So when do we use odds ratios and when do we use relative risks? So we tend to use relative risks for randomized controlled trials or cohort studies. Odds ratios we use for case control studies when we're not able to assess the true risk. If we use odds ratios in randomized controlled trials, we can markedly exaggerate the effect size in randomized controlled trials if we misinterpret the odds ratio as a relative risk. And this can mislead us. Now, if we've got is very low, so for example, if the baseline risk is 1 in 100 versus 1 in 101, there's not much difference between the odds ratio and the relative risk. But if our baseline risk is much lower, for example, 1 in 4, then you can see that there's a big difference between the odds ratio and the relative risk ratio. So in large studies with a small baseline risk, there's not a lot of difference. But where the baseline risk is less, then there is more of a chance of there being a difference between the odds ratios and the relative risk ratio. Hope that's all clear. Thank you very much.